Alright, so today we're going to be talking about Ohm's law. We're going to first look at the electric field. So we talked about charges when we talked about Coulomb's law, and now we're going to look at charges and how they affect a circuit. So every electric charge is surrounded by an electric field, and these fields cause forces. So as we said, we have positive and we have negative. If we have two of the same, so positive and positive, they will repel. If we have a negative and a positive, they are going to attract. We have the electric potential, which we look at the this measured in volts, also known as voltage, and you can think of the electric pressure like the pressure in a water hose. So if you turn up the water in a water hose, it's going to cause more water to go out of the hose. Same thing with voltage. If you increase the volts, it's going to cause that current in the wire to increase as well. And then we have the electric current. This is what is actually flowing through the wires. This is measured in amps. And we can see that we have a battery here. And we have our electrons, which are negative. And they are flowing through the current to the positive side of the battery. So again, that the voltage is the push for the charges, and the electric current is actually what is flowing through the wire, and that's measured in amps. And in order for this to occur, there must be some type of potential difference. And in order to get that, we can either use a cell, which we consider these batteries. We can use generators, and this voltage or this pressure is going to cause those electrons to move through that conductor or the wires, and that is how we get that flow to occur. Then we can talk about resistance. So resistance, we're going to be looking at 4 different things that can cause resistance in a circuit, and that would be wire conductivity. You want to have you want to have a wire that can conduct electricity, so usually it's copper or anything like that. We have the wire length. So the shorter the wire, the less resistance you're going to get. The longer you get, the more resistance you are going to see. The wire thickness, so you want to have the thickest wire possible in order for you to have a less resistance. And then temperature, you want to keep the wires as cool as possible, because if they get too hot, then you're going to get a lot of resistance. So here's an example. We're going to be talking about circuits a little bit later, but these are the 3 factors that we look at when we look at circuits and Ohm's law. We have the voltage, which comes from the battery. We have the actual current, which is what flows through the wires, and then we will have resistors, which is kind of represented as a squiggly line. So again, we have voltage, current, and resistance. Then we can look at Ohm's law. It looks at all 3 of these variables. Current is going to be directly proportional to voltage, meaning the more voltage you have, the more current you're going to get. So more voltage equals more current. And then current is inversely proportional to resistance, meaning the more resistance you have, that's going to equal less of the current. So they're indirectly proportional. And then there is a formula to go along with this. Current equals voltage divided by resistance. And we have a triangle down here. So we have our V represented as voltage, our I represents current, and our R represents the resistance. If you look at this right here, it is the same formula, but those are the units. So for current, you're going to be using amps. For voltage, you're going to be using volts, and then for resistance, you'll be using ohms as the unit. And then this is just some letters to also abbreviate that formula. formula. So all of these, this, and this are all the same formula, just written either with the word, the abbreviation, or the letter. And again, we have the triangle with the voltage on top, current, and resistance on bottom. So here are the three formulas that you will be using to find the different variables. We have the voltage equals current times resistance, current equals voltage divided by resistance, or resistance equals voltage divided by current. So now you're going to complete the practice worksheet.